The geology of Zurich, Switzerland is centered around its magnificent lake. The landscape is the product of a long and layered geologic history, shaped by plate tectonics, ancient sedimentation, glacial sculpting, and modern urban adaptation. The city is built atop the Swiss Molasse Basin, a foreland sequence of sandstones and conglomerates formed 20 to 30 million years ago during Alpine uplift. These rocks record the transition from marine to fluvial environments as the mountains rose and eroded. In tectonic terms, Africa is generally sliding beneath Eurasia. But in certain zones, like here, slices of African-affinity rocks were scraped off and thrust over the European margin. These now form part of the Alpine thrust belt south of Zurich, structurally overriding the Molasse Basin. During the Ice Ages, this terrain was dramatically reshaped. At the peak of the last glacial maximum, around 20,000 years ago, a major glacier advanced down the Limit Valley, carving deeply into the molasse. As it retreated, it left behind a classic over-deepened trough, a U-shaped valley well below the surrounding terrain, later partially filled with glacial and post-glacial sediments. This trough now hosts Lake Zurich. The Limit River, which drains the lake today, inherited that glacial pathway and continues to follow the ancient meltwater route. Zurich's city center now sits on a mix of glacial outwash and alluvial deposits, soft, water-bearing sediments that support aquifers but require careful engineering for foundations and flood control. After deglaciation, early populations were drawn to the valley floor. By 5000 BC, Neolithic communities were building lakeshore dwellings on wooden piles. Some remain preserved beneath modern lake sediments near the river mouth. They took advantage of water, fertile soils, and elevation. In the modern era, Zurich's geologic risks include slope instability in the Zeal River watershed. Steep hillsides of glacial till and weathered molasse remain susceptible to landslides, especially during heavy rain or earthquakes. The Silsea Reservoir upstream adds complexity. In a worst-case landslide or dam breach, floodwaters could reach Zurich's central train station within 2 hours. Zurich's building materials also reflect this geologic inheritance. Many historic structures feature local Bollingen sandstone, a freshwater molasse, as well as alpine limestones and crystalline rocks from other regions. These stones provide durability and reveal Switzerland's geologic diversity. Zurich, like all communities, is not merely built on geology. It is shaped by it. From the form of its lake and valleys to the risks of landslides and floods, the geologic past continues to guide how the city grows and adapts. Understanding that foundation is essential to managing both the opportunities and the challenges. Contact Magnet Geological for your real estate due diligence questions.